Solving quadratic equations using square root property and completing the square method. A quadratic equation is an equation written in the form ax squared plus bx plus c equal to 0, where a is not equal to 0. If a is equal to 0, this is not going to be a second degree equation anymore. It will be a linear equation then. And this form of equation is called the standard form. Some textbooks refer to it general form as well. Zero product property we've talked about before when we solved quadratic equations using factoring. If two numbers have a product of 0, then one of them must be 0. If x minus a times x minus b is 0, then either minus a is 0 or x minus b is 0, which means either x is equal to a or x is equal to b. Square root property. Square root property says if x and k are complex numbers and x squared is equal to k, then x is equal to plus minus square root of k. When we go ahead and take square root on both sides, we add plus minus in the front. Might be easier to think about in terms of numbers. If x squared is equal to 25, then x has two possible options. X can equal positive 5 or x can equal negative 5. So when we take square root on both sides, we add plus minus in the front. Okay. When to use this method? When we have quantity squared is equal to a number given to us. Quantity squared is equal to a number, or we can write the equation in the form of quantity squared equal to a number. Here's some examples. The first example, y squared minus 24 equal to 0. So our goal will be to first isolate the quantity squared. Once the quantity squared is isolated, we can go ahead and take square root on both sides. So we're going to isolate the quantity squared, which will be y squared equals 24. Now we're going to take square root on both sides. When we take square root on the left hand side, y squared square root would be just equal to y, and square root of 24 is on the right hand side. And we can break that 24 into pieces. 24 is 6 times 4. We can pull a 2 outside the square root. So y is equal to plus minus 2 root 6 are our two solutions that make this equation true. Next, y plus 3 squared equals 16. We're not going to try to FOIL y plus 3 squared because it's already in the form that we want. Quantity squared equal to a number. So go ahead and take square root on both sides. Go ahead and take square root on both sides. When we take square root on the left hand side, we would have y plus 3 squared square root equals plus minus square root of 16. On the left hand side, square root and square cancels. Y plus 3 is equal to plus minus square root of 16. So this leaves me with y plus 3 equals plus minus 4. So y plus 3 equals 4 and y plus 3 equals negative 4. So we get y equals 4 minus 3, 1 is my one solution, or y equals, if we subtract 3 from both sides, y is equal to negative 7. So these are our two solutions. These are the two values of y that will make the given equation true. So if you plug y as negative 7 or y as 1 in both of those, our left-hand side and right-hand side will be equal. See another example. This one looks like a bit more complicated, but first step would be to isolate the quantity squared. So we're going to go ahead and subtract 48 from both sides. So 3 times 5y plus 2 squared equals negative 48. Now we're going to go ahead and divide both sides with 3 to isolate the quantity squared. That's negative 48 divided by 3, which is going to be negative 16. So 5y plus 2 squared is negative 16. Now go ahead and take square root on both sides. Square root on both sides. So 5y plus 2 squared square root. When we take square root, we don't forget to add plus minus in the front. Now we have a negative inside the square root on the right hand side. That's going to be an imaginary number. Square root of negative 16 is 4i. So plus minus 4i on the right hand side, and left hand side square root and square cancels each other. So now we can get the y alone by writing two separate equations. 5y plus 2 equals 4i. 5y plus 2 equals negative 4y. 5y is equal to negative 2 plus 4i. y would be negative 2 plus 4i divided by 5. And from the second equation, 5y is equal to negative 2 minus 4i. Y is equal to negative 2 minus 4i divided by 5. So there's our two solutions that make our given equation true. If we plug y as any of these, they both make the given equation left-hand side equal to right-hand side. Now, review of perfect square trinomials. In previous section, we looked at perfect square trinomials foiling. So there are some binomials I have foiled. Let's see a quick relationship between the middle term and the last term. So in all these, the middle term is 6 in the first one and the last term is 9. So if I cut the middle term in half and I square it, I get the last term, right? If I cut the middle term in half and square it, I get the last term. If I cut the middle term in half and square it, I get the last term. Cut the middle term in half and square it, I get the last term. So to complete a square, we will need to cut the middle term in half and square it. And that's going to give us a perfect square trinomial like the 4 examples we have here. So how can I complete the square for the bottom 2 examples? For example number 1, we can cut the middle term in half and square it. 8 divided by 2 is 4. 4 squared is 16. So if I do that, this is going to be a perfect square trinomial, which is x plus 4 squared. And if I FOIL x plus 4 squared, I would be able to get this expression back. Next, cut the middle term in half. Negative 10 divided by 2 squared, which is going to be 25 or 5 squared, whatever you want to write. Both are okay. Both are correct. I could write 25 instead. So that is a perfect square trinomial. Now let's look at the method for completing the square, solving quadratic equations by completing the square method. First step is we want to make sure the coefficient of leading term or coefficient of x squared is 1. If that's not 1, we'll have to make it 1 by dividing everything on both sides with whatever the coefficient is for x squared. Then write the equation in the standard form where variables on one side, constant on the other side. Complete the square. Once we complete the square, we're going to go ahead and use square root property and get the variable by itself. Let's see some examples. The first example, x squared plus 4 is equal to 1. On the left-hand side, my goal will be to move the constant term on the right-hand side, and it's already on the right-hand side, which is good. So on the left-hand side, my square is not completed. What number should I add here to complete my square? Remember, cut the middle term in half and square it. So cut the coefficient of x, which is b, cut the b in half and square it. So 4 divided by 2 is 2 squared. I'm going to be adding 2 squared to both sides. And now I'm ready to complete my square. In my perfect square, I pull out an x, pull out 2, and the sign of the middle term. If it's positive, I will write plus here. If it was negative, I'll write minus here. Now, don't feel like you lost anything. This expression, x plus 2 squared, is still what we had in the last step. So x squared plus 4x plus 4. If you open up the bag, you can see that you didn't lose any terms. These two expressions are still equivalent to each other. So we haven't lost any terms. X plus 2 squared equals 1 plus 4. Now, right-hand side would become 5. Left-hand side is x plus 2 squared. At this point, I have quantity squared equal to a number. So I'm going to take square root on both sides. Square root on both sides. It's an equation. Whatever we do to one side, we must do it to the other side as well. So I'm left with x plus 2 equal plus minus square root of 5. On the left-hand side, square root and square cancel each other. Lastly, we are going to isolate the x, and there's our two solutions, negative 2 plus root 5 and negative 2 minus root 5. See one more example. X squared plus 3x minus 1 equals 0. Well, in this case, that 1 over here is not completing my square, so I'm going to move this 1 to other side. So I am going to be writing this equation by moving 1 to the other side, and I'm leaving some empty space over here to complete my square. What should I add to complete my square? It's the coefficient of x term divided by 2. Coefficient of the middle term, the number next to x, divided by 2 squared. That's the magic number. If I add it to the left-hand side, I will have a perfect square trinomial. Now, because it's an equation, I cannot just go about adding something to one side. I need to add this number to both sides of the equation because I need to keep this equation balanced. If I do something to one side, I must do it to the other side as well. In the next step, I'm ready to complete my square. I pull an x, pull a 3/2, and whatever is the sign of the middle term, that comes in the middle. X minus 3/2 squared equals 1 plus 3 squared is 9, 2 squared is 4. And the right hand side can be simplified. I can combine these two fractions by getting the common denominator, multiplying top and bottom with 4. Once we have common denominator, we add the numerator, so 13 divided by 4. Next step, I have x minus 3/2 squared equals 13 divided by 4. Go ahead and take square root on both sides. When I take square root on the left-hand side, square and square root cancel each other. And the right-hand side, we would have square root of 13 over 2, because square root of 4 is 2. Lastly, it's my goal to get the x by itself, so I'm going to go ahead and add 3/2 to both sides. 3/2 plus minus square root of 13 over 2, and we can write it as a single fraction by getting a common denominator of 2 under under the entire numerator. See one more example when our leading coefficient is not equal to 1. So we always must make the leading coefficient equal to 1 before we can complete the square. So I would have to divide everything on both sides, this equation, with a 3 to get a 1 as a leading coefficient. Now, what should I add here to both sides to complete my square? Remember, whatever is the number next to x, half of that number squared is what should be added to both sides. So that's my magic number. That's 1/2 of b squared. That's what that needs to be added to both the sides. Even if the b is negative, when we square that negative is going to disappear, even if the b was negative. So we will always be adding that number. Even if your b is negative, we're never going to be subtracting that number. Okay, so 1/2 b squared, which we can simplify to 2/3 squared. And if I do it to one side, I must do it to the other side as well. Let's go ahead and complete my square now. X comes here, 2/3 comes here, sign of the plus sign goes in the middle. On the right hand side, we have 5/3 plus 4/9. Let's combine the like terms on the right hand side to get into a single fraction. So that's 15 plus 4 over 9, which is 19 over 9. So x plus 2/3 squared equals 19 over 9. Go ahead and take square root on both sides. Go ahead and take square root on both sides. So that turns out to be x plus 2/3 squared square root equals plus minus square root of 19 over 9. All right, so on the left hand side, square root and square cancels. X plus 2/3 is all we're left with. Right hand side, square root of 19 cannot be simplified anymore, but we can pull out the square root of 9 as 3. Last step, to isolate the x, we would be subtracting 2/3 from both sides, and we do have our single fraction, and our solutions are x equals -2 plus minus square root of 19 divided by 3. That's all for this video.